Welcome pre-cal students to the homework help video. The assignment is here in front of you and hopefully this will be a help to you. Numbers 83 through 89 we are told to graph the logarithmic functions. So let's go ahead and start with number 83. Step 1, you need to take the argument and set it equal to 0. So x plus 3 equals 0. And then we solve and we get x equals negative 3. So now we know where the vertical asymptote is. Now, I should have had this done already, so give me 1 second, please. I need to get a copy of one of these tables or one of these coordinate planes. There we go. All right. And we are back. There we go. Okay. Now, moving on. So anyways, the first thing you want to do is you want to find the vertical asymptote by taking the argument, setting it equal to 0, and solving. And we did that. We got negative 3. So we know that we have a vertical asymptote at negative 3. Now, here's what you need to decide. Either you're going to plot points to the right or to the left. And the only way to know is to put in a negative 4 and a negative 2 and see which one of those two numbers gives you out no solution. Well, obviously negative 4 is not going to work because if you put a negative 4 right here, a negative 4 plus 3 is a negative 1, thus you're taking the logarithm of a negative number. So negative 4 is not going to work, and so we are going to plot points to the right of the vertical asymptote. So here are the numbers that you should put into the table of values for your graph, okay? We're at negative 3. We want to get real close to that vertical asymptote, so negative 2.9. I'm going to put negative 2 in for x, and so negative 2.9, so next would be negative 2, and then negative 1, and then 0, and then 1. Okay, so here we go. Let's go ahead and get started substituting these values in. Now, first of all, I'm going to put a negative 2.9 in right here, negative 2.9, and a negative 2.9 plus 3 is a 0.1. So I really have logarithm base 2 of 0.1. So with my calculator, I'm going to quickly take log of 0.1, enter, divided by the log of 2, enter, and that gives me negative 3.3. Okay, now we're going to put a negative 2 in for x. Negative 2 plus 3 is 1. So now we're going to find the log base 2 of 1. Okay, so very quickly with my calculator, log of 1, enter, divided by log of 2, enter. And of course you will get 0. Okay, so I'm going to go ahead and put a 0 right here. Now let's put a negative 1 in for x. Negative 1 plus 3 is 2. So now I'm going to take the log base 2 of 2, and that should give me a 1. Now let's put a 0 in for x right here. 0 plus 3 is 3. So I know now I'm going to take the log base 2 of 3. So we have the log of 3, enter, divided by log of 2, enter. And you should get 1.6. Now let's put a 1 in for x right here. 1 plus 3 is 4. So now we're going to take the logarithm of 4, log base 2 of 4. So we have log 4, enter, divided by log 2, enter. And that gives you 2. So let's plot those 5 points. Negative 2.9 is negative 3.3. Negative 2 is 0 right here. Sorry about that. Negative 1. Let's see, negative 2 would be 0, negative 1 would be 1, 0 is 1.6, and 1 would be 2. So we're getting our standard curve here for this graph looking something like this. Okay? Alright, moving on to number 85. Okay, now please remember in a problem like this, students, your argument is not x minus 1. If there was parentheses around it, then your argument would be x minus 1. There's no parentheses, so your argument is just x. So we have x equals 0, and there's really no solving to do, and so we know our vertical asymptote is at 0. So here is my vertical asymptote. Now the only question we have to answer is, am I going to plot points to the right or to the left? Well, let's put a -1 in and a 1 in and see what happens. We know we can't put a -1 here because the logarithm of -1 is undefined. And so we know we're going to have to go to the right and plot numbers to the right. And that helps us with our table of values. So we're going to go barely to the right of the vertical asymptote, and we're going to put in 0.1. And then we'll put in 1, 2, 3, and 4 because we're going to continue to move to the right of the vertical asymptote. Now if I put in a 0.1 right here, remember the first thing you're going to do is this. You're going to take the logarithm base 3 of 0.1. So in other words, I'm going to hit log 0.1, enter, divided by log of 3, enter, and then hit -1. In other words, it'll look like this. Log of 0.1 divided by log of 3, and then whatever you get out, you then hit -1. Okay, and if you do that correctly, you're going to get -3.1, -3.1. Okay, and so let's go ahead and continue on. Let's take a look now if we put 1 in for x. Okay, so we're putting a 1 right here for x. So what I would have would be log base 1 divided by log base 3, and then whatever you get, -1. Okay, so here we go. Log 1, enter, divided by log 3, enter, and then -1, enter, and you will get a -1. Okay, now let's put a 2 in for x. We're going to put a 2 right here. So now we're going to take log base 3 of 2 and then -1. So really what we have is log 2, enter, divided by log 3, enter, -1. So log 2, enter, divided by log 3, enter, and then -1, enter. And I think I hit a wrong button there. Let's see. Yeah, I did. Hold on one second, students. Log of 2, enter, divided by log 3, enter, -1, enter, gives you -0.37. -0.37. And now let's put a 3 in for x right here. So now we're going to put a 3 right here. So log base 3 of 3 -1. Now I can tell you right now, if I take log of 3 divided by log of 3, I will get 1, and 1 minus 1 is 0. Now I'm going to put a 4 in for x, and so basically what I have now is log of 4 divided by log of 3 minus 1. So log 4, enter, divided by log 3, enter, -1, enter, gives you a 0.26. And now we're ready to go ahead and graph this logarithmic function. All right, so here we go. Let's go ahead and do this. All right, 0.1 is -3.1. 1 is -1. 2 would be -0.37. 3 would be 0, and 4 would be 0.26. So again, you're kind of seeing the standard curve that we usually get for logarithmic and exponential functions. And there it is. All right, let's take a look at number 87. Number 87. Now this will be a little easier because we're dealing with the natural log, and our calculator does natural log for us. But first of all, let's find the vertical asymptote. Let's take our argument, which is x. Let's set it equal to 0, and of course there's no solving to do. X equals 0. So my vertical asymptote is going to fall right on 0. Okay, now I've got to decide whether I'm going to put numbers in to the right or to the left. Obviously it's going to be the right, because if you put -1 in for x, you're taking the logarithm of -1 or -2 or -3. So there's no way you can put negative numbers in for x. So my table of values is going to start with, well, we want to get real close to the asymptote and then work our way to the right. So I'm going to start with 0.1 and then put in 1, 2, 3, and 4. Okay, so here we go. I'm going to take the natural log of 0.1, enter, times 4, enter, and you will get -9.2. negative 9.2. Now let's put a 1 in for x, so the natural log of 1, enter, and then times 4, enter, would be 0. And now the natural log of 2, enter, times 4, enter, would be 2.78. And now the natural log of 3. So natural log of 3, enter, times 4, enter, is giving you 4.4. And now we'll put a 4 in for x. Natural log of 4, enter, times 4, enter, gives you 5.5. So we're ready to sketch our graph. Okay, we really like the functions that are natural logs or common logs because our calculator does those for us automatically. Okay, so they're pretty simple to do. Okay, our first point is 0.1 and then negative 9.2, which is something way down here. And then 1 would be at 0, 2 would be at 2.78, 3 would be at 4.4, and 5 would be at 5.5. So a little bit of a curve. Looks like this one's going to be curving more gradually, it looks like, which is fine. And then shooting off way down here to this point. Okay, and that's good enough. We're just sketching and getting a basic idea of what the graph looks like. Okay, number 89. Well, once again, I mean, we'd still do it the same way. We take our argument and we set it equal to 0. My argument is x, so x equals 0. So I do know that my vertical asymptote will be at 0. Now we have to decide whether we're going to plot points to the right or to the left, whether the graph lies to the right or to the left. Well, it's obvious it's to the right. There's no way you want to put negative 1, negative 2, or negative 3, or negative 4, or any negative number in for x, because any negative number right here means you're taking the logarithm of a negative number, and that's just not going to work. It's undefined. You cannot do that. So we know for our table of values we're going to start very close to the vertical asymptote, and then we're going to move to the right. Okay, so my first number is going to be 0.1, and then 1, 2, 3, and 4. Now in the last problem, notice we were multiplying the natural log times 4. And so we could take the natural log first, hit enter, and then times 4 and enter. With this problem here, I want to strongly encourage you to type into your calculator 2 minus the log of 0.1, enter. Type the whole thing in. It'll be a lot easier than doing this. If you don't do that, here's what you have to do. You have to take the natural log of 1, enter, and then what's in front of it, actually be the natural log of 0.1, and then hit enter, and then what's in front of it, a negative 1, so then hit times negative 1, and then plus 2, because you have a positive 2, and that's really a pain. So I would encourage you to type in 2 minus the natural log of the number. Okay, so now we're going to put 1 in for x, so I would type into your calculator 2 minus the natural log of 1, and you will get out 2. And then type in 2 minus the natural log of 2. And if you type that in correctly, you'll get 1.3. And then type in 2 minus the natural log of 3, and you will get out 0.9. And then type in 2 minus the natural log of 4, and you will get 0.61. So we're ready to sketch the graph here quickly. 0.1 is up at 4.3. And then 1 is up at 2, and then 2 is 1.3, 3 is at 0.9, 4 is at 0.61, and there we go. So there's the graph coming down, hitting here, and there is no horizontal asymptote, so as it goes further to the right, it will continue to get lower and lower, okay? And then we have the graph getting closer to the vertical asymptote. Okay, so there's the first 4. Now on these next 4, there's a couple curveballs. Look at this first one here. Now if you remember, I've taught you this is an exponential function, and I've taught you how to graph these. However, I really haven't taught you how to graph these. And here's why I say that. All the ones that you've graphed so far, your exponential functions, had y by itself. And that makes a huge difference, students, a huge difference. Okay, so what I want to encourage you to do, since you don't have y by itself over here, I would encourage you to write this logarithmically. Remember how to do that? You can take a logarithmic function and write it exponentially. You can take an exponential function and write it logarithmically. Remember how to do that? First of all, we say our base stays a base. So base 3 is base 3. My number here that's all by itself, or my x, is my argument. And then y goes over here, and look at that. Now I have a good old-fashioned logarithmic function, and now I'm ready to go. So the first thing I'm going to do, because we have learned how to graph logarithmic functions, we take the argument and we set it equal to 0, so x equals 0. So my vertical asymptote lies at 0. Now, I have to decide whether I'm going to put in 1 or negative 1 for x. Am I going to work my way to the right, or am I going to work my way to the left? Well, the answer is obviously to the right, because if you put a negative 1 in, or negative 2, or negative 3, you're taking the logarithm of a negative number, and that's not going to work. So for our table of values, we're going to barely go past the vertical asymptote, which will be 0.1, and then we're going to put in 1, 2, 3, and 4. So 0.1, and then 1, 2, 3, and 4. And having done that, here we go. Now remember, you're putting in a 0.1, so you really have log of 0.1 base 3, and your calculator doesn't do base 3, so you have to do log of 0.1 divided by log of 3. Okay, so here we go. Log 0.1, enter, divided by log of 3, enter, and you'll get negative 2.1. Of course, I'm rounding. Now we're going to take the logarithm of 1. So it would be log of 1 divided by log of 3. So log of 1, enter, divided by log of 3 will give us 0. Now we're putting a 2 in for x right here. A 2, so we would type in log base 2 divided by, or log of 2 divided by log of 3. Log of 2, enter, divided by log of 3, enter, and you will get 0.63. Now we're going to put a 3 in for x right here, a 3, okay? And log of 3 divided by log of 3, enter, divided by log of 3, enter will give you a 1. And then we're going to put a 4 in for x right here. So log of 4 enter divided by log of 3 enter will give you 1.3. So we are ready to go ahead and graph this now. At 0.1 I'll be at negative 2.1. At 1 I will be at 0. At 2 I will be at 0.63. At 3 I will be at 1. And 4 I would be at 1.3. And then go ahead and sketch your graph, and it's going to have that normal curve shape to it, and we're ready to move on to number 3. Okay, number 3 once again is an exponential, but notice y is not all by itself, so because of that I want to encourage you to write this logarithmically. Okay, so your base is 1/2, so I'm going to write log base 1/2 of x equals y. And now we're ready to go, students. Look, take your argument and set it equal to 0. X equals 0, so I know my vertical asymptote will be at 0. And then obviously if you look at your function right here, there's no way you want to put in negative 1 or negative 2 or negative 3 for x, because you're going to get undefined. So it's obvious your table of values needs to start at 0.1, which is barely past the vertical asymptote, and then put in 1, 2, 3, and 4. So here we go. I mean, if you put a 0.1 in for x right here, a 0.1, notice your calculator does not do base 1/2, so you're going to have to type into your calculator log of 0.1, enter, divided by log of 0.5, or 1/2, and that would give you 3.3. Now we're going to put a 1 in here for x, a 1, so I'm going to type into my calculator log of 1, enter, divided by log of 0.5, enter, and you will get 0. Now I'm going to put a 2 in for x right here, so I'm going to type in log of 2, enter, divided by log of 0.5, enter, and I will get a negative 1. A negative 1. Now I'm going to put a 3 here for x, which means I'm going to type in log of 3 enter divided by log of 0.5, and I will get negative 1.6. Negative 1.6. And then a 4 for x, so I'll put a 4 right here. So I'm going to type in log of 4 enter divided by log of 0.5 enter, and I will get a negative 2. So the graph will look like this. At 0.1 I am at 3.3. and at 1 I am at 0. At 2 I'm at -1. At 3, -1.6. And 4 is -2. So again, we see the normal standard curve that comes with a logarithmic and an exponential function, either one of those, okay? So there we go. All right, two more left. Number 5. Now, number 5 is already written in logarithmic form, so we're thankful for that. And so we can just go ahead and take our argument, set it equal to 0, x equals 0, no solving to do. So I know that I have a vertical asymptote at 0. Now, obviously, you're not going to put in numbers for x like -1, -2, or -3 because you would get out undefined. That's not going to work. So your table of values obviously is going to start at 0.1, which is barely past the vertical asymptote, and then it's going to go on to numbers like 1, 2, 3, and 4. So here we go. We're going to put in a 0.1 right here, and so what we have is log of 0.1 equals divided by log of 3 equals, and you're going to get -2.1, -2.1. Now we're going to put a 1 in for x right here, so we have log of 1 enter divided by log of 3 enter, and you're going to get 0. Okay, now we're going to put a 2 in for x. So we're going to type in log of 2 enter divided by log of 3 enter, and you're going to get 0.63. Okay, now let's put a 3 in for x, and you're going to type into your calculator log of 3 enter divided by log of 3 enter, and you will get 1. And then we're going to put 4 in for x, so we're going to type in log of 4 enter divided by log of 3 enter, and you will get 1.3. So students, we are ready now to quickly sketch this graph. We have one problem left, and we'll be finished with the homework. So at 0.1, we're at -2.1. At 1, we're at 0. At 2, we're at 0.63. At 3, we're at 1. And 4, we're at 1.3. So there's a graph going down, okay? And then, of course, it continues going this way, too. So there we go. One more and we're finished. Number 7. Okay, now it is a logarithmic function, so it's already written in logarithmic form. Take your argument, which is x, set it equal to 0 and solve. And of course we don't have to solve, and so we know we have a vertical asymptote at 0. Okay, so that's pretty simple enough so far. Now let's go ahead and write our table of values. To me it's obvious. We are not going to go to the left of the vertical asymptote. If we do, we're putting numbers in for x like -1, -2, -3, and you can't take the logarithm of a -1 or a -2 or a -3. So we're going to go to the right of the vertical asymptote, which means we'll put in 0.1 to get real close to it, then 1, 2, 3, and 4. So here we go. This is the type of problem here where you can you can actually hit 2 first if you want. 2 times the natural log of 0.1, enter, and you will get -4.6. These are the easy ones because your calculator does natural logs. You don't have to use the change of base formula. So next I'm going to type in 2 times the natural log of 1, and I will get 0. And then 2 times the natural log of 2, and that will give me 1.4. And then 2 times the natural log of 3 will give me 2.2. Of course, I'm rounding these. And then 2 times the natural log of 4 gives me 2.8. 2.8. All right. So with that in mind, let's sketch the graph and we're finished. Okay. 0.1 goes to -4.6, which is about right here. 1 is at 0. 2 is at 1.4. 3 is at 2.2. And 4 is at 2.8. All right. And there's our graph, looking pretty standard, okay? Pretty normal. Okay, that's it. I hope this homework help video has been a help to you. Call or email if you have any questions.